Information is a source of learning, but unless it is organized, processed, and available to the right people in a right format for decision making, it is a burden, not a benefit. Hi, and Hariom children. Today's topic is information processing. Before moving into the topic, let's start the session with prayer.
ॐ सहना भवतु सहनौ पुनक्तु सह वीर्यं करवावहै तेजस्विनावतीतमस्तु मा विद्विषावहै ॐ शान्ति शान्ति शान्तिः हरि ओं श्रीगुरुभ्यो नमः हरि ओम्.
Here is a quick recall on the basics of information processing. Information processing is a theory of learning that explains how stimuli that enter our memory systems are selected and organized for storage and retrieved from memory. Information processing theory. These theories focus on internal mental processes that occur as opposed to external behaviors. The mind takes in information, performs operations to change its forms, stores it, and retrieves it when needed. The three major categories are sensory memory, working or short term memory, long term memory. Learning objectives. At the conclusion of this chapter, learners will be able to do the following: classify types of memory and attention resources, describe principles of human machine interface, demonstrate understanding of information coding by humans, describe methods to evaluate and design user instructions and warning.
And in this video, we will explore what is information processing. We will look at what it is, how does it work, why it's important, and I'll also share some examples to illustrate it. If this is your first time on this channel, then make sure you subscribe and hit the bell icon to get updates on my latest videos about time management and productivity. The easiest way to explain information processing is through Atkinson and Shiffrin memory model that demonstrates it quite clearly. We are constantly processing huge amounts of information, even when we think that we're doing nothing. As you look around, you might see grass, trees, buildings, and birds, and for you to recognize them, you have to register this information. We experience our environment and surroundings through 5 senses: vision, sound, smell, touch, and taste. This processing takes place in our sensory memory that lasts anywhere from milliseconds to a few seconds, as it's enough to register the information. The next step is your short-term memory. You might see the stone on the ground, but you're probably not going to act on it as long as you don't want to kick it around. But some information grabs your attention, and this selective information moves into your short-term memory. Maybe you see the mobile phone on the ground and decide to pick it up. Once information is in your short-term memory, it will stay there for about 20 to 30 seconds until it's either forgotten or moved to your long-term memory. Also, it's worth mentioning that our short-term memory has a limited capacity, and on average, people can keep about 7 pieces of information at any given time. Then, from short-term memory, some information will be moved to long-term memory through the process called encoding. Information will be then stored in your long-term memory and retrieved in the future through the process called recall. I hope that you enjoyed this video and I was able to give you a quick overview of what information processing is and how does it work. If you enjoyed this video, I would really appreciate if you could press the like button, as this will help the video reach more people and spread the message.
Tetrominos. Okay. Before learning about tetrominos, we should know what are dominoes. Okay. Have you heard this word? Yes, every one of you heard this word, but with a different meaning. Okay. You may tell what is domino.
If we had 4 cubes that are connected, lying flat, not stacked on top of each other, what are all of the possible arrangements that we could make? Let's talk about dominoes for a second. A domino is 2 squares that are put together. The only way to arrange those 2 squares where they're lying flat is like this. And it doesn't matter if it's lying down flat or standing up, but the only arrangement of a domino looks like that. But what if we added 2 more squares? What are the possible arrangements we could make? Those are called tetronymos. How many different tetronymos could you make? Or, in other words, how many different ways could you connect these 4 squares? The cubes must be connected with the full side touching the full side of another square, and it must lie flat. Let's do one together. I could take a square and put the full side of another square right here, touching the other square. And I could put a square here and a square here. This shape right here is called a tetronymo. It's made from putting 4 squares together, but it's not the only tetronymo that exists. What other possibilities exist? Pause the video and get out a piece of paper and try to draw as many different tetronymo shapes that you can. Remember, you must use 4 squares, they must be connected, and the side that it connects to another square must be completely covered. Let me show you a bad example. These are not tetronymos. While they do use 4 squares and are touching each other, the full sides of some of the squares are not connected. Like right there, that makes that shape not a tetronymo because the full side of this shape and the full side of this shape are not touching. This is not a tetronymo because it touches 2 sides at the same time. The same here, and full sides not here. So these are not tetronymos. I don't want you to try to create these. I want you to try to find all the tetronymos that actually work and follow all the rules. Unpause the video when you think you have all of the possibilities. Do you think you have all of the possible tetronymos? How many did you get? Are there some that look the same as others? Are some of your tetronymos the exact same as another one? You just have to flip it, turn it, or slide it, and it still makes the same shape. How many different possibilities are there? Using 4 squares to make as many tetronymos that follow the rules that I explained, you should be able to find 5 different types. We're going to compare with a partner later, so make sure you try to find all 5 different ways that you could combine these 4 squares and make 5 different tetronymos.
In the game of Tetris, there are 7 pieces, each made up of 4 square units. The shapes are called tetrominoes in mathematical literature. Can you use one of each piece to form a 7x4 rectangle? If so, find a way. If not, prove why it's impossible. I thank Dr. Perkins for sending me this delightful problem. Can you figure it out? Give this problem a try, and when you're ready, keep watching the video for a solution. The answer is that it's impossible, and we will demonstrate the solution by using a graph coloring. Consider a 7x4 rectangular grid. Color the squares alternately light and dark like a checkerboard. This is one way you could color the squares, but this is not the only way. You could actually color the squares in another pattern. But in either case, there are an equal number of 14 light squares and 14 dark squares. Now let's consider a coloring of the tetrominoes. First, let's consider the following 6 tetrominoes. Let's imagine coloring the squares alternately light and dark like a checkerboard. This is one way you could color each piece, but there's another way that you could color the pieces. But in either case, each piece always has an equal number of 2 light squares and 2 dark squares. These 6 pieces always have 12 light squares and 12 dark squares. Now let's consider the T tetramino. What happens when we color it like a checkerboard? Here's one way you could color it, and here's another way. The T tetramino always has 2 more squares of one color. Either it has 1 light square and 3 dark squares, or it has 3 light squares and 1 dark square. So, if we could make a 7x4 rectangle using one of each piece, then the 7 tetraminos would combine for a total of 14 light squares and 14 dark squares. But 6 of the tetraminos always have the same number of light and dark squares for a total of 12 light squares and 12 dark squares. The T tetramino, however, creates an asymmetry. It either has 3 light squares and 1 dark square, or it has 3 dark squares and 1 light square. Using one of each piece, we will either have a total of 15 light squares and 13 dark squares, or a total of 15 dark squares and 13 light squares. The 7 pieces can never combine to have exactly 14 light squares and 14 dark squares. Thus, it is impossible for them to form a 7x4 rectangle. Did you figure it out?
This is a monomino. Domino is another. There are 2 types of triminos: straight trimino and right trimino. Now guess how many tetraminos will be there? The answer is 5. They are straight tetramino, square tetramino, L tetramino, skew tetramino and T tetramino. This is a rectangular shape using monominos and tetraminos. Now the question is it possible to form a rectangle with all the 5 tetraminos?
map or street map is a map that primarily displays roads and transport links rather than natural geographical information. It is a type of navigational map that commonly includes political boundaries and labels, making it also a type of political map.
Actually, just a few months back, I went to the British consulate for the first time, and I had no idea what the British consulate looked like. And so what I did was I typed it into Google Maps. I just typed in British consulate in San Francisco, and it pops up on the map. I click on Street View, and I was able to see the building, the street it's on, and the neighborhood. And it blew me away. I knew exactly where I was going even before I got there. Once I knew where it was, I sent that information to my phone. So once I find a location in Google Maps, all I do is click on Get Directions. And then I type in the location that I'm in, which is actually auto-completed by Google because it saves all my locations. I then press Go, and it routes me directly to the British consulate. Right before the meeting, I check out the traffic. If I see any kind of obstruction or any traffic on 101, which is what I usually take, I'll just easily drag it over to 280 and it'll route me to the right direction. I had a follow-on meeting with my colleague over at the Palace Hotel. I just typed in Palace Hotel, clicked on Get Directions. I noticed that it was using car directions, so I just clicked on walking directions and it gave me a more direct route. When I got my new walking directions, I easily sent it off to my colleague. What I had done before, I would copy and paste map information into my email, and now all I do is a single click. Google Maps is basically the easiest way to get map information.
Here is a quick recap on today's session. Graphic organizers improve students' creative, analytical, and critical thinking skills as it helps students of all ages to process information. Presenting information in both visual and verbal improves recall and recognition. Graphic organizers' ability to show relationships clearly builds upon and increase a student's prediction on her background knowledge. Learning outcomes. Understand the issues, topics, and aspects of the cognitive sciences in general and human information processing in particular. Identify and discuss the basic research findings in human information processing with respect to human sensation, perception, attention, memory, knowledge representation and organization, language, decision making, problem solving, reasoning, and creativity. Analyze, apply, and evaluate basic research findings in human information processing to business and technology environments.
Let's do some eye exercises.
Sit down on the ground comfortably. Without moving your head and neck, look upwards and then downwards. Keep your neck and back straight. Now look at the sides, alternating with the left and right. Do not move your neck while looking sideways. Now look to your left, then look upwards. Move your eyes right and then look down. Look upwards, to your right, and then down. Now look upwards, then to your left and down. Now alternatively, look to your left once after looking upwards, before looking down, and then look to your right the next time after looking up. Close your eyes and rest for some time. Sit comfortably and bring your hands straight forward at shoulder height and raise your thumbs. Look at your thumbs. Slowly spread apart your hands. Look at your left and right thumbs alternatively while spreading your hands apart. Bring your hands.
ॐ सहना भवतु सहनौ भुनक्तु सह वीर्यं करवावहै तेजस्विनावतीतमस्तु मा विद्विषावहै ॐ शान्ति शान्ति शान्तिः हरि ओम श्री गुरुभ्यो नमः हरि ओम।